Good day and welcome back for part 3 of our discussion on substitution. As we've mentioned previously, substitution is a technique of integration that undoes the chain rule of differentiation. And intuitively, with that idea, based upon the form of the integral we are hoping to evaluate, we might be prompted to make a substitution. We typically want to think of choosing u to be something inside another function. And we would like to take this integral that's complicated or difficult for us to evaluate. It only involves the variable x, and we would like to rewrite it in terms of a simpler, easier to evaluate integral, only in terms of the variable u. And remember, when u is equal to gx, du is g prime x dx. So very conveniently, we can express this as f of u du, which we hope is simpler and easier for us to evaluate. Once you evaluate, remember this final step for indefinite integrals is to resubstitute and get it back in terms of that original variable x. So with this in mind, we have 2 additional examples to work. And note there is a small typo. The power of cosine should simply be a 1. What I would like to ask you to do is to use substitution to evaluate both of these integrals. If we were meeting in person, I would give you 10 or so minutes to work through these examples, and then we would come back together to discuss. So with that in mind, I would strongly urge you to pause your video and give yourself all the time you need to evaluate these, and then come back to the video for a discussion. So hopefully at this point you've paused the video and you've thought a bit about these 2 indefinite integrals. As indicated, we are going to use a substitution to evaluate both of them. That's really the only possible approach we have at this point. And to come up with a choice of u, remember we typically want to pick u to be inside another function. And in this case, with the sine squared of x, sine is inside another function. And I'm going to actually just rewrite this algebraically to make sure we all see that. Sine squared is really the function sine being squared. And now it's more clear that sine is inside another function. If we let u be equal to sine of x, du is cosine x dx. So we can see this is going to work out very quickly and very efficiently. In terms of u, it's simply the indefinite integral of u squared. That would be 1/3 u cubed plus c. And then remember we resubstitute. So every u needs to become a sine. So 1/3 sine cubed plus c. We'll take the same approach with this remaining example. In order to use a substitution, we need to make a choice for u. And with this intuition that u should be an inside function, I think there's only really one good choice that we could make. You have the square root of x inside cosine. It's also in the denominator of a fraction. So it's really the only inside function that we see. So let's go ahead and try u equals the square root of x and see what happens. So if u is the square root of x, du is 1/2 square roots of x dx. And just to make our integrand a bit more clear, we certainly could write this as cosine of the square root of x times 1/the square root of x dx. So square root of x inside the cosine is going to play the role of u. What we would like to happen is this 1/, square root of x to end up being somehow related to du. And in this example, I will just go ahead and manipulate this quantity in the integral and make it look precisely like the du, which is just a slightly different approach than we took previously, but the algebra is the same. What I would like to happen is have this be 1/2 square roots of x. But note, I can't just divide the integrand by 2. That would change it. But what I can do is multiply by 1. So if we're dividing by a 2, we also need to multiply by a 2. And remember, 2 is a constant that we pull out front. So this would become 2 times the integral of cosine u du. Note alternatively, if you prefer, and it's just a matter of preference, you can say 2 du is 1 over square root x dx, which shows precisely where this extra 2 came from in front of the integral. And antiderivative of cosine is sine, and because it's a substitution with an indefinite integral, our final step is to resubstitute. So we replace the u with square root x. So 2 sine square root x plus c. And that finishes up our current discussion. And once again, I'd like to recommend that you take plenty of time and practice suggested problems. Throughout the remaining sections we encounter this semester, integration, and specifically substitution, will play a very important role, but they will be a smaller part of maybe a larger problem. So we want to be quick and efficient with evaluating these integrals. So stay tuned. Take care.